Hi, this is Tag again, and today I want to do a voltmod guide, general mod guide / overview on the ASUS A7N8X-E Deluxe. Now, this board here is, I would say, one of the best options for socket A. Unfortunately, it does need a bunch of mods that other good boards don't. I'm not saying like it is the best in terms of pure performance, but like you can actually buy these compared to something like a DFI or a well, you can buy the A-bits, but the A-bits tend to die, at least for me. So anyways, basically I want to show you how to make a decently overclocking board out of one of these. Now let's swap this one, this is the stock one, for a modded one. Now I just recently got a bit more into socket A again. Basically I had to deal with my trauma of socket A A-bits always dying on me. I had 3 of the A-bits and well, all of them are dead now. And they didn't even last very long. So I decided to give ASUS a go. I got me 2 of these here. They are relatively easy to find and relatively cheap usually. Anyways, let's start on what I did to this board so far. Now, usual stuff. If you have ever even watched like 1/10 of a video from me, you probably know that I hate aluminum electrolytic capacitors. So these are old polymers. Now, unfortunately, I ran out of the good stuff. So these are 1500 2.5 volts from a dual socket 940 board I killed. One of those 13 euro boards. Nothing important, but still those are salvage, and I don't even know where that one is from. I didn't have 5 of the same, so I added a 1200 microfarad 4 volt OSCON here. Kind of unfortunate, but it should work. Now, input filtering. Maybe you have seen the previous video on this board. I did the 12 volt rail mod, which means I have had to replace the input filtering. Those are 3 330 microfarad 16 volt Nippon Chemicons. Should be good. Now this is significantly less input capacitance than the stock board, but I figured that since the on pulse basically of the high sides is way shorter, because they're running on 12 volts now, we should need less capacitance, and basically we want like faster delivery of our power. So I decided that this should be good. On the oscilloscope it looks decent, so not too terrible. Also, compared to some other 12 volt mods I saw, I decided to keep, or not actually keep, yes, keep the input filtering inductor to basically take some load off the power supply. Not that I think a modern like 2 kilowatt power supply will care if there is an input filtering inductor, but like I just stuck to VRM design basics here basically, for once, me being safe. Also, I didn't take my ground wires and attach them to some random ground. I attached them directly to the ground closest to the FETs. So the path of the current is basically the shortest. Anyways, that's enough for Vcore. Actually, no, it's not enough for Vcore. We of course have a feedback mod here, just your regular feedback mod with a 20 kilo ohm potentiometer. Nothing special here. Then we have Vmem here. Now the great thing about the ASUS board and Vmem is that Vmem is fed from 5 volts. So these 2 purple ones are our input filtering for Vmem, and then there is 4 output filters. So basic feedback mod again, and it lets us raise Vmem basically wherever we need it. I don't think we will need more than something around 3.6 to 3.8 volts on here. So zoom out. Then there is, some people call this VDD, Vagp, whatever. It's basically the main voltage rail that supplies your chipset here, your Enforce 2 Ultra. Now, there is also a feedback mod here, like this, goes all the way over here. Again, I replaced the caps and I added some more stuff on the back. Let me show you in a second. Same stuff as usual, my measurement points. I like to glue them to useless boards, so this is some of the 5.1 audio, parallel port up here. No one needs those for overclocking. Let's zoom in. Now you can see some more fancy stuff. Those are 5 Panasonic SP caps, 3 times 330 microfarads, 2 times 470. Since I basically went down in capacitance on the big caps on the output filter of the main Vcore VRM, I decided to kind of offset it by putting some really low ESR capacitance directly behind the CPU. I also did this on the P5E3 ASUS boards a lot. So that's just something I like to do, basically move it closer to the CPU. Other than that, oh yeah, measuring points. Let's start with Vcore. Any of the main 5 filtering caps are good measuring points. And you can, if you have a mod like this, you could of course solder it to the outside here or here, directly behind the socket, but I don't like to do that because then you basically have an antenna attached directly behind your socket that might go past your VRM or your MOSFETs rather. That's the reason basically I like to attach voltage measuring points, unless they're oscilloscope for a ripple or something, to the bulk caps of the VRM, not the stuff directly behind it, or in case of memory directly to the power pins of the memory slots. I'm not sure this does anything, but it's just something that might do something. Anyways, I also added some, I'm pretty sure you can't see this, there is more MLCCs populated here. I added like 100 microfarads of is it 0603? 0603 I think this package is, 0603 MLCCs on here. Because usually chipsets scale with like stabilization directly next to them. Also, there's MLCCs on the 2 output filtering caps for the VDD rail. Those are 47 microfarads as well. I don't think they will do a lot, but I just added them because I felt bored. Also, VDD rail or AGP rail measuring points here, the right pin. And on this one it should be the, how is the orientational caps of this board? It should be the lower pin. So here the lower pin is also a measuring point you can use. This one is Vmem. No, this one is Vmem obviously. This one is Vcore. Vmem. For Vmem you can use this cap, this cap, this cap, this cap as measuring points, easily accessible. I think that's about it for the hard mods. Now, oh actually that's not it. This ASUS board has some BIOS quirks because they, I'm not sure if it's the first bit or the last bit on top of my head, of the frequency or multiplier table that you can't set via BIOS, or you can set. I found some BIOS that supposedly has that in BIOS, that basically you can set higher multis than 12.5. or lower multis than 12.5 if your CPU automatically pulls that bit high. So this is just a switch that switches the FID either 0 or 4 bit, I'm not sure right now, between Vcore and ground. So it's just a regular old switch. Again, all of the mods in detail in Paint later. So I think that's about it for hard mods on these. There is a bunch of BIOS modding stuff that I haven't yet really fully understood, I would say, but I will put a BIOS that I'm using on this, and in the quick test seems to be good, in the description. There's like a bunch of different versions of BIOS. Some are better for efficiency, some are better for high FSB. So yeah, it's a whole rabbit hole to go down. Right now I have a BIOS by a German guy called digitalbath on here. Seems to be decent. Quick test I did on the board, it posted 270 FSB just fine, which it obviously didn't do with stock BIOS. But yeah, if I ever do a video on that, I will do it once I understand the whole BIOS modding stuff on this platform better. It basically has to do with some sub timings, either between CPU and Northbridge or just memory timings. Anyways, I think that's it for the overview. I will now move on to the computer and the detailed voltmod stuff and FID mod, so multiplier mod here.
Okay, here we are. As usual, let's start with Vcore. Now, all of these are feedback mods, so this is going to be pretty simple. 1, 2, 3, 4, 5, 6. Here we are. That is the feedback pin. And you can also use this, 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 or this. Personally, I used the last one here. From there, usual stuff. Variable resistor. What's ground? Now for a value, I would suggest something like 20k. Actually, let's make it 20 to 50 kilo ohms. Ground spots in this area. Now, usually I recommend screw holes, but this is not a screw hole. This is, well, it is a screw hole, but this is for the CPU cooler, so don't use that one for once. You can use this capacitor here on this side or the upper side of this one. Personally, I use the I/O, like the metal on the one of the I/Os, I think above the first network port. So I only have to run one wire from my variable resistor onto the board. So anyways, that's Vcore. Let's move on to the next one. That is memory voltage. Now, same as usual, feedback mode. Feedback pin is this one here. There is a nice unpopulated pad right here. Also connected is this here and this here. So from there, usual variable resistor, ground. For a value here, I would go with basically the same as on the CPU. Though I wouldn't really use 20, wouldn't really use 50 here, so something like 20 kilo ohms is perfect for this. Maybe 50. it's not optimal to use 50. You don't have like as fine control, and basically half of the variable resistor is going to do very little at that point. Anyways, ground points here. There is a nice screw hole up here. And you could also use, if you want something close, the bottom of this capacitor. Now let's move on to the next one, which is our VDD, or chipset voltage, AGP voltage, whatever you want to call it. The pin in question here is this one. Yeah. Also available on these two pads. Make it like this. Okay. Now here it's a bit different. This has relatively high resistance by default. So personally what I have here is a variable resistor in series with a regular resistor, then to ground. Now you can only use a variable resistor, but well, problem is here, 1 to 2 mega ohms. That's the issue here. Personally, I use 500K here and 1 mega ohm here. Now, basically the reason I do this is that I haven't yet seen any or have any 2 mega ohm potentiometers. So if you find one, you can also just use that. You can also use something different here in series, because actually mine is, I think, 560K, so something around half a mega ohm here would be perfect. Now ground points, the left of these two, and there's an unpopulated pad for some IC here. This is also ground. Again, I use the shield of some of the I/O on the like back I/O of the motherboard, so I only have to run one wire across the board. Now, the next one is the frequency multiplier mod, rather. Now, with this one, it's basically, this is your FID pin, and you want to have, in a sense, 2 switches here from this. That one would be ground. The other one would be Vcore. So you basically switch the pin between low and high. Now, the usual old school way of doing it is connecting it with either this pin here. This is ground, the upper one, so let's make it blue, I guess. This is a ground pin. Let's make the bottom one red. This would be a Vcore pin. So basically what you do is switch them between these two. Actually, yeah. So in my case, I just have the switch with 3 legs that switches between ground and Vcore. So I only had to run one wire from this pin to my switch. Another thing you can do here is sort of a BSEL mod, basically hard modding the FSB your CPU is running at. Now the relevant pin for that is, let's see, there's actually 2 of them. Up here one, and there is one of them. Then this is the other one. What you want to do with those 2 is really easy as well. Basically you want a switch on each of them. This is wrong. Switch on each of them. and then lead them to ground. Now let me quickly check something. So basically none of them grounded would give you 133 megahertz FSB. Just the bottom one here grounded would give you 166, and both of them grounded gives you 200. Personally, so far I didn't need this mod. That's why you didn't see it in the showcase. I'm just putting it here because it's something you might want to do. Now, I don't think you necessarily need it on this ASUS board, but you're going to definitely need it on some boards that have less overclocking options in BIOS. So this is more of a general thing. Classical way of doing this usually is soldering wires between either of them and this pin here, because this is a ground pin. Anyways, I think that's, oh actually, let me use this opportunity to mark my power planes here. Now, this massive one here in the middle, all of this, all ground. But you saw me solder the capacitors too. So this would be all ground, and this whole thing here is Vcore. Same as this one. And these islands here are ground. Here, there, there, there. This one I'm not sure. And this and this. Okay. So this is useful if you want to add capacitors, like scratch your own pads and add capacitors. Just be very careful that you don't scratch over any of those wires here. Now these wires here are basically wires on the power plane you're scratching. But these are wires contacting through different signals basically. So if you solder across this here with your Vcore tab for the capacitor, you're shorting out some internal other traces, so that's no good. Just keep that in mind. I think that's it for this motherboard. I hope you enjoyed it, and well, have fun with the Socket A platform. Personally, I still have a lot to learn, but at least the hard mod stuff I usually get down pretty quickly. Bye.